Hello everyone, welcome to another video. So today we're going to learn speed time graphs. So this will be quite a long video because there's a lot of things to explain. So you can see that a speed time graph it can look many ways, but the y-axis will be speed and the x-axis will be time. The units can change because in this case it is meter per second and then it's seconds. It can be kilometer, it can be hours, it depends, right? So how to read the speed time graph is actually very simple. So here the y-axis is just the speed. So you can see that in this story, I started at, when I first start, I'm already moving at some speed. The speed keeps increasing. At some point, the speed stopped changing. But am I still moving? Yes, because I'm still moving, just that the speed remains the same. I keep moving at the same speed, I'm still moving. And then after that, my speed decreases until at some point my speed becomes 0 and I stopped. Okay, so that's mainly how you read the graph. So what is the two things that you must learn in speed time graph? Number one, the gradient of a speed time graph is acceleration. See over here, accelerate. So it's actually the gradient. So the gradient of this line is how fast it is accelerating in this portion. And then same thing, gradient here is the acceleration of here. So you can see that this line, the gradient is 0. Why? Because the acceleration is 0. So the speed remains at 18. Did it go faster and slower? No, it didn't move at all. So it didn't change. So the acceleration is 0. The speed remains the same. That's why the gradient is 0. And over here, you can see that the acceleration is negative because the gradient is negative. The speed keeps going down. Of course, it is decelerating. That's why the acceleration is negative. Okay, so that's theory number one. The next more important one is actually the area under graph of a speed time graph is the distance traveled. Okay, so for example, you can see that this line is here. The area under this line will be this whole part here, this trapezium. So the area of this trapezium is the distance traveled from 0 to 20 because the line is here. The area under the graph is here. So that's theory number 2. Very important theory. You can see that every single question will play on this. So with these two theory, let's see how we put these two to use. Okay, so question number 1, they say the truck accelerates at 0.7 in the first 20 seconds. So 20 seconds, which means this is the graph. And they're supposed to find V. So like we do our first theory, the gradient is the acceleration, and they say the acceleration is 0.7. That means the gradient of this line over here is 0.7. So how to find gradient? Y minus y divided by x minus x. So which 2 points? Obviously it has to be this point and this point, because that's the only 2 points with numbers. So you can see that this point will be 20, 18 here. This point will be 0 V. So this is the 2 points I used to find the gradient. So it's V minus 18 divided by 0 minus 20. Exactly here. The gradient equal to 0.7, just like the question say. And from here, I cross multiply, shift the 18, I solve for V. And once I find V, I like to put a 4 here, so I know that this 4. Okay, next. They say what the truck travels at constant speed for a distance of 252. So constant speed meaning what? The speed remains at 18 and it didn't change. It's here, right? This whole stretch, the speed is 18 and it didn't change. And they traveled for 252. That means the area under this line is 252, which means this area, which is a rectangle, the area is 252 and ask you to find T. So T, very simple. Area of rectangle, we learn in primary school, length times breadth. How long is this? Don't know. How long is this? 18, right? 18. So this is 18. So 18 times something is equal to 252. So how do we write this something down? Instead of putting as x, you can put it as T minus 20. Correct, because here to here is 20, here to here is T. Sorry, the T not very obvious. Let's make it thicker. Okay, so T is here. Okay, so it's T minus 20. You get this. So that's why in my working, you can see that it's 18 times T minus 20 equal to 252, and then I expand, I solve, is 34. So this distance here is 34. This t is 34, sorry. Okay, done. And then after that, I want what? Find the speed of the truck after 50 seconds. So it's actually here. So 50 is somewhere here, right? So this 30 something, this is 50. So 50 is here. If I go up, I need to find this speed. So this is actually, you can do it a few ways. You can do it as ratio, or you can do it as similar triangle. So what I do is I do similar triangles in this case. So 50, 60. So this is 10, right? So here, triangle, 10. I'm drawing this triangle out, triangle, 10. This one, I don't know, right? This distance, I don't know. And then I draw a bigger triangle, which is the whole thing, this whole big triangle. So this is 34. So here to here is 26. Here to here is 18. So 18. And these two triangles are similar. So in order to find x, is basically x divided by this equal to this over this. This is similar triangle, basic of similar triangle. It's over here. So x divided by 18 here equal to 10 divided by 26. I times the 18 over, my x is 6.92. And then of course I round to 3SF. This is the rounded off version. Okay, so next I want average speed for the whole journey. So this is a bit harder to calculate because we need the total distance divided by total time. Let's settle the time. For the time is more obvious. So for the whole graph, I start from 0, I end at 60. That's why the time is 60. Now how do I calculate the total distance? So like we said, area under the graph is the total distance traveled. So that means this trapezium, this rectangle, and this triangle add together is the total distance. So I need to count. So let's start with trapezium first. So trapezium is half times this plus this. So this is 4, this is 18. So you can see over here is half times 4 plus 18 times the height of the trapezium, which is here, 20. So the trapezium is done. This one is rectangle, so it's just length and breadth. So this is 14, this is 18, 18 times 14, basic primary school. This is triangle, triangle is half base times height. So the base will be 26, the height will be 18. So half base times height. If you calculate all, is 706. So the distance divided by time is like that, 3SF, and the unit is meter per second. Just be careful, it's meter per second. Okay, so that's how you do this question. Let's look at another question, also pretty elaborate, but this one will be a shorter question. So let me adjust the screen a little bit. Okay, so the diagram is below, the question is on top. So let's read the diagram, read the question. So blah, 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 first t seconds. Okay, so t seconds, the speed is like that. Okay, it goes faster, 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 then after it maintains. Then calculate the speed when the time is 18. So where's 18? This is 20, so 18 must be here, right? Somewhere here. So again, this is similar triangle. So I need to draw that two triangles. So the smaller triangle is over here, and the bigger triangle is over here. And again, these two are similar. So let's draw the bigger triangle. So here to here is 20, and then here to here is 50 minus 8, so it's 42. So it's 20 and 42. So the smaller one will be 18, and then this distance I don't know. So it's 18 and x. So just like similar triangle, to find x over this equal to 18 over 20 here. Times the 42 up, you get 37.8. Now be careful, this distance is 37.8, but they are asking for the speed when the time is 18. So this number is the answer. This distance is the 37.8. So is this number 37.8? No, this is 37.8 plus 8. That's why the speed is actually 37.8 plus 8. This is common sense, be careful. Okay, so next, ask you to find t if the distance traveled in the first t second is 1.6 kilometers. So again, we are using the concept area under the graph is the distance traveled. So distance traveled is 1.6 kilometers. Now this is being a bit nasty because the unit here is meter per second. So if you count the area, it is actually in meters. So, but they purposely give you 1.6 kilometer, quite nasty. So this is actually must be written in meters, which is 1600 meters. And then we count the area under graph. Because until t, until t, you don't know what's t, right? But there's two things here, trapezium and square. You can see the whole thing as a trapezium also can. Oh, cannot, sorry. So here, there's a part here, so cannot. So this must be trapezium plus some sort of rectangle. So let's do trapezium first. So this is 8, this is 50. So it's half 50 plus 8, and the height of the trapezium, 20. Trapezium done. Now this is some sort of rectangle, right? So same thing. The here is 50 because of this 50. So this length or breadth is 50. And this is not, this whole thing is not t, because the whole thing is t. So this part over here is just t minus 20. So 50 times t minus 20, add together should be equal to 1600. So we form the equation, and then we just calculate every single thing. So this is a number. If you press calculator, you get 580. This one you times the 50 in, you get here. You shift around, you get 22.4, and that will be the answer. So hope you learned something. Thank you and bye-bye.